going to learn Unit 3 Fluids. Dear student, why a small iron nail sinks in water but a huge ship of heavy mass floats on a sea water? Why? Why astronauts have to wear a special suit while traveling in space? What is the reason? All these have a common reason called pressure. If the pressure increases in a solid based on its inherent properties, it experiences tension and ultimately deforms or breaks. When you apply pressure on solid, what will happen? It starts breaking. This is because the particles are already packed closely together so that solids cannot be compressed easily. In the case of fluids, it causes them to flow rather than to deform. Why? Liquids are usually considered incompressible. Inside the liquid, the molecules are already close together so that it is difficult to compress them anymore. So, liquids are flowing rather than to deform. Deform means break. Although liquids and gases share some common characteristics, they have many distinctive characteristics on their own. Gases are easily compressible, but liquids are incompressible. Learning of all these facts helps us to understand pressure better. In this lesson, you will study about pressure in fluids, density of fluids, and their application in practical life. Let's see all these topics. Pushing a pin into a board by its head is difficult, but pushing it by the pointed end is easy. Why? Have you ever wondered why a camel can run in a desert easily? Why a truck or a motor bus has wider tire? Why cutting tools have sharp edges? In order to answer these questions and understand the phenomena involved, we need to learn about two interrelated physical concepts called thrust and pressure. When you stand on loose sand, your feet go deep into the sand. Now lie down on the sand. What happens? You will find that your body will not go that deep into the sand. Why? In the both cases of the above activity, the force exerted on the sand is the weight of your body, which is the same. This force acting perpendicular to the surface is called what? Thrust. So this force acting perpendicular to the surface is called what? Thrust. When you stand on loose sand, the force is acting on an area equal to the area of your feet. When you lie down, the same force acts on an area of your whole body, which is larger than the area of your feet. Therefore, the effect of thrust depends on the area on which it acts. So, the effect of thrust on sand is larger while standing than while lying. So, what is thrust? The force applied on a surface in a direction perpendicular to the surface. That is thrust. So, force acting perpendicular to the surface is called what? Thrust. Its SI unit is Newton. Symbol is N. Now, what is pressure? The effect of thrust per unit area is called pressure. So, pressure is a scalar quantity. How to find the pressure? We have formula. Formula for pressure is equal to thrust by area. Its SI unit is Pascal. It is denoted as PA. 1 Pascal is equal to 1 Newton per 1 meter square. Why it is very painful. A single nail pricks our body. Why there is a less pain when you lie down on a bed of nails? This is because area of contact is more. A larger area in contact with the nail tips means pressure from any one nail is very low. So larger area and less pressure. Now we'll see the topic of fluids. All the flowing substance, both liquids and gases, are called fluids. So what is fluids? A fluid is any substance that has no definite shape and has the ability to flow. Both liquids and gases are fluids. Example, air can flow and has no definite shape. Like solids, fluids also have weight and therefore exert pressure. When fluid filled in a container, the pressure of the fluid is exerted in all directions and at all points of the fluid. Since the molecules of a fluid are in constant, rapid motion, particles are likely to move equally in any direction. Therefore, the pressure exerted by the fluid acts on an object from all directions. So, pressure is on all sides of the object no matter what its shape. So, pressure is perpendicular to the surface of the object. Okay. So, pressure in fluid, how to calculate the pressure in fluids? We have the formula to calculate pressure in fluids. Formula for calculating the pressure in fluids, its SI unit for pressure is the Pascal PA, which is equal to 1 Newton per 1 meter square. Pressure in pascals is equal to force in newtons by area in meters square. So for pressure P is equal to, for force is F by area A. So what is the pressure formula? P is equal to F by A. We shall first learn about the pressure exerted by liquids and then learn about the pressure exerted by gases. Now pressure due to liquids. We can see in this figure the pressure is acting on all sides of the vessels. Why? The force exerted due to the pressure of the liquids on a body submerged in it and on the walls of the container, that is always perpendicular to the surface. So in this we can understand pressure will act on all sides of the vessels. First we saw the pressure will act on all sides of the vessel. Now liquid pressure exerts force upwards. When an air-filled balloon is immersed inside the water in a vessel, it immediately comes up and floats on water. This shows that water exerts pressure in the upward direction. That is why it comes upward. Okay, so in this what you understand, water exerts pressure in the upward direction. Similarly, liquid pressure acts in lateral sides also. When a bottle having water is pierced means hole, on the sides we can see water coming out with a speed. This is because liquid exerts lateral pressure on the walls of the container. In this, we can able to understand liquid exerts lateral pressure on the walls of the container. Now, factors determining liquid pressure in liquids. Pressure exerted by a liquid at a point is determined by depth. It is denoted as H. Density of the liquid, it is denoted as rho. Acceleration due to gravity, it is denoted as G. Let's do an activity to understand pressure varies as depth increases. Okay, take a large plastic can. Punch holes with a nail in a vertical line on the side of the can as shown in the figure. Then fill the can with water. The water may just dribble out from the top hole, but with increased speed at the bottom holes as depth causes the water to squirt out with more pressure. From this activity we can infer that pressure is various as depth increases, but it is same at a particular depth independent of the direction. Let's do another activity to understand pressure which depends on density of the liquid. Take two liquids of different densities, say water and oil, to the same level in two plastic container. Whatever oil you can take. Make holes in the two containers at the same level. What do you see? It can be seen the water is squirting out with more pressure than oil. This indicates that pressure depends on density of the liquid. Last one is the acceleration due to gravity. So the pressure due to a liquid column. Take a tall beaker is filled with liquid so that it forms a liquid column. Okay, so the area of cross section at the bottom is capital A. The density of the liquid is rho. Already we know that. The height of the liquid column is what? H. In other words, the depth of the water from the top level surface will take it as H. So we know that thrust at the bottom of the column, F is equal to weight of a liquid. Thrust is equal to force and force is equal to thrust. Okay, so F is equal to what? Weight of the liquid. What is the formula for force? F is equal to mass into acceleration due to gravity. So F is equal to small m and small g. If you want to find out the force, we have to know mass of the liquid. Okay, so we can get the mass of the liquid by multiplying the volume of the liquid and its density only. So first you need to find out the mass of the liquid. So what is the formula for mass? M is equal to rho into volume. Okay, that is density into volume. So M is equal to rho into V. That is the second equation. Now you have to find mass of the liquid. So how you will find the mass of the liquid? Mass of the liquid is equal to density into volume. You have to know what is density and what is the volume. Volume of the liquid column V is equal to area of cross section A into height H. So by multiplying these two only will get volume of the liquid column. So when you multiply, what is the volume of the liquid column? A into H. You take that is the third. Okay. Now substituting 3 in 2. Okay. We got the third equation. Now substitute 3 in 2. What is 2m is equal to rho into volume. Okay, that is density into volume. So in that we are going to substitute the volume. Okay, so rho into what? Volume is AH, area of cross section, into height. Okay, so now you got the mass of the liquid. Mass of the liquid is equal to rho into area of cross section into height. Now this one you take it as 4. Now substituting 4 in 1. You already know first one. What is that? Force is equal to mass into acceleration due to gravity. In that formula we are going to substitute this fourth one. So mass is what? Rho into AH and gravity. Okay, now we want to find out the pressure. What is the formula for pressure? P is equal to thrust F by area A. Already we know that formula for force, M into G, and area is A. So is equal to, what is force that you want to substitute in this? Okay, so rho into A into HG. That's what we got by A. the area of cross section AA get cancelled. So what you will get finally, rho into height into gravitation. Okay, rho is the density, h is the height, and g is the acceleration due to gravity. Finally, what we got, pressure due to liquid column P is equal to h into rho into g. So this expression shows that pressure in a liquid column is determined by depth, density of the liquid, and acceleration due to gravity. So interestingly, the final expression for pressure does not have the term area A in it. Thus, pressure in liquid depends on what? Depth only.